In this question, they give us three different functions, f of xy, g of xy, and z of xy. And they're asking us to evaluate the given functions at these 2 points, as well as they would like us to state the domain of the function. So let's get started. So for part A, the function f of xy is equal to x plus y cubed. So f of xy is equal to x plus y cubed, which means if I'm interested in evaluating this function at the point x equals 0 and y equals 2, we have f at 0, 2 is equal to, wherever I see an x, I replace it by 0. Wherever I see a y, I replace it by 2. So this becomes 0 plus 2 cubed, which is equal to 8. So that's the first one. And f at 2, 3 is 2, negative 3 is the next one they would like. If I evaluate this function at x equals 2 and y equals negative 3, I replace the x by 2 and the y by negative 3, so I get plus negative 3 cubed. This becomes 2 plus negative 3 cubed is negative 27, so that. And of course 2 minus 27 is negative 25. For the domain, when we're looking at domain, we're always interested in what values for x and y can I not plug into this equation or this function. And what we see here is usually what we're looking for are places where the denominator of a fraction is 0. We're looking for places where a logarithm, the argument of the logarithm is negative or 0. Or we're looking for places where things inside square roots or even roots are negative. In this function, x plus y cubed, we don't have any logarithms, we don't have any fractions, and we don't have any square roots. So in this case, the domain is any x and y are any real number we can imagine. For part B, the function that they give us is g of xy is equal to e to the xy. And so first they would like us to evaluate this function at 0, 2. So g at 0, 2. We replace the x by 0, we replace the y by 2, so we have e at 0 times 2. And of course, 0 times 2 is just 0, so this is e to the 0, which we know is equal to 1. The other point that they'd like us to evaluate g at is the point 2, negative 3, in which case we replace all the x's by 2's and all the y's by negative 3, and so what we end up with is e 2 times negative 3. And of course 2 times negative 3 is negative 6, so this is just evaluated to e to the negative 6. As for the domain, again, we're looking for places where the bottoms of fractions might equal 0. We're looking for values of x and y where square roots or even roots might be negative, and we're looking for places where logarithms might be 0 or negative. We don't have any logarithms, we don't have any square roots or even roots, and we don't have any fractions, so again, the domain for this is all real numbers. So x and y can be anything that we want in this situation. Question C, we have that z of xy is 1 over x squared plus y squared. So we have z of xy is equal to 1 over x squared plus y squared. First, we'd like to evaluate this at 0, 2. So z at 0, 2 is equal to, we replace all the x's by 0's, all the y's by 2's, so 1 over 0 squared plus 2 squared, and of course that's equal to 1/4. 0 squared is 0, plus 2 squared is 4, 0 plus 4 is 4. So this is 1/4, and then they also want us to evaluate this at x equals 2 and y equals negative 3, so I'm going to stick a 2 in wherever I see an x, and a negative 3 in wherever I see a y. So sticking in the 2, I get 1 over 2 squared plus negative 3 squared. The 2 squared is 4, the negative 3 squared is 9, 4 plus 9, and that's equal to 1 over 13. Now as for the domain, we start out with any real number, but what we want to do is we want to throw out any numbers, any combinations of x and y that make the bottom of fractions equal to 0, any even roots. We don't want any negative numbers inside even roots, and we don't want 0 or any negative numbers to be inside of any logarithms. We don't have any logarithms, we don't have any even roots, but we do have a denominator, and that denominator is x squared plus y squared. So what we're looking for is we want to make sure, first we'll take our domain to be any real number. X and y can be any real number, but we don't want the situation where we have a 0 in the denominator. If we think about this, any number that we plug in for x is going to be squared, so that's going to be a positive number. Any number we plug in for y, when you square it, that's going to be a positive number. So we're going to add up two kind of positive numbers here. And so this seems like it's going to be no problem no matter what we plug in, except in the case where if x equals 0 and y equals 0, we're going to get 0 squared plus 0 squared, which would give us a 0 in the denominator. So what we want to do is we want to make sure that x comma y does not equal 0, 0. Of course, x by itself could equal 0. We had that situation. We were able to plug in 0, 2. Y could equal 0 as long as both x and y are not 0 at the same time. So this would be the domain of this function.